Moving right along, it is my pleasure to introduce our next speaker, all the way from Novosibirsk, Russia, Dmitry Ushakov, BricsCAD Mechanical product owner. He and his team will showcase the power of BricsCAD's 3D modeling technology. So let's connect with Novosibirsk. Dmitry, please take over.
Hello, my name is Dmitry Ushakov, and in the next 45 minutes, together with my colleagues, we'll present you the main new features of BricsCAD Mechanical version 21. If you did not hear about BricsCAD Mechanical before, then you probably imagine it as just another toolset to create 2D mechanical drawings. While 2D drafting is perfectly possible with BricsCAD, we at BricsCAD strongly believe in 3D. Three-dimensional modeling allows designers to catch and fix errors at early design stages, analyze different aspects of design products, generate manufacturing and maintenance documentation. And a rich set of tools for 3D mechanical design is available already in BricsCAD Pro. You can create your part from scratch or rework any existing part using direct editing operations in combination with 3D constraints, which allow you to express design intent in form of logical and parametric relationships between faces, edges, and vertices of 3D solids and surfaces. The powerful technology of parametric blocks and components serves a base for top-down and bottom-up assembly design, where the same 3D constraints play the role of assembly mates, which allows you to easily assemble your products and analyze kinematics of its moving parts. In your assemblies, you can use more than 1,000 parametric standard parts of different categories: fasteners, machine parts, structural shapes, and piping. BricsCAD Pro also allows you to find collision between parts and compare their geometry. Drafting toolset is also very rich. You can generate live sections, associative drawing views, and parametric animations from your 3D model. Because DWG is de facto standard in our industry, it will cover most of your needs in data exchange. BricsCAD Pro also supports import and export in other popular formats like ACES and Rhino. You may ask, if BricsCAD Pro is so powerful, why do I need Mechanical as a vertical product on top of it? This is because BricsCAD Mechanical adds a number of important functions to streamline the most typical design and documentation tasks of mechanical engineering. In particular, it provides a powerful toolset for sheet metal design. It allows you to configure your bills of materials, to compute mass properties of your assemblies, create exploded representations, and add balloons to assembly views in just a single click. By the way, the library of parametric standard parts will require mechanical license since version 22. And as a mechanical user, you will probably also need Communicator for BricsCAD, which allows you to exchange in a number of additional industrial formats, including many standard and native CAD formats. While BricsCAD Mechanical is not a toolset for 2D drafting, it is also not just another mainstream 3D mechanical CAD. There are serious differences of BricsCAD from such software as Inventor or SolidWorks. First of all, with BricsCAD you don't need to spend your time and money to study a completely new software with its own GUI and design principles. With BricsCAD you will always remain in the same familiar environment, which was extended with few intuitive tools. Second, with BricsCAD, you will be more productive thanks to our unique technology of 3D parametric components and hundreds of vertical applications from our partners. You can easily implement your own tool or application using Lisp or BRX API. Third, BricsCAD doesn't pretend to replace your current CAD system. It is ready to collaborate in multi-CAD environment. You can continue to use different CAD tools, but with BricsCAD you will never have headache with different file formats which lose design intent in translation. I believe no other CAD system in the world has so powerful tool set to rework imported geometry using a combination of direct editing operations with automatic history-free parameterization. Every year, our quality assurance engineers test new functions of BricsCAD Mechanical on a completely new model. And this year, we were inspired by the idea of multi-scroll mechanism. This is a gear mechanism that translates a continuous rotation of the driving wheel to intermittent rotation of the driven wheel. It was modeled in BricsCAD using 3D constraints and expressions. And this movie was recorded in BricsCAD using Animation Editor, which allows you to create complex scenarios of 3D parametric animations with different effects, including appearance or disappearance of particular parts, kinematic simulation, and camera movement. As you can see, our multi-scroll mechanism is a subassembly of the filling and cutting machine. Through conveyors, the bottles are moved under some filling valves that inject the liquid into them. And after the filling, the bottle moves off to the other side of the machine, where a cap is provided for each of them. And by the way, this model has parameters which allows you to easily adapt it to bottles of different size. And it is a large assembly. It consists of more than 3,000 parts, of which over 500 parts are unique. Of course, this machine is a part of a brewery, which also has a lot of vessels connected with pipe to a water supply and the machine. And a number of standard parts are used here, which is also very typical for many other industrial assemblies. This complex model was designed in BricsCAD Mechanical from scratch, using new and improved tools available in version 21. We extended the main toolsets, sheet metal design, assembly design, and joint generation with the most requested tools. These tools will be presented by my colleagues in the rest of this session using that brewery model. As in the previous years, Ilya Tatarnikov will perform all operations in BricsCAD in live to demonstrate the real performance of each of them. And now, I'm inviting to the stage my good friend Christian Lecomte. During many years of his outstanding professional career, he took part in the development of several software solutions, but sheet metal toolset in BricsCAD is his masterpiece. Welcome, Christian.
Thank you, Dmitry. Hello, everybody. My name is Christian Lecomte, and I will now speak about sheet metal. This year again, we have a significant number of very useful new features, as you can see on this slide. We will summarize all those functions in live at the end of this presentation. But right now, we will demonstrate in live the most powerful of them using two sub-assemblies of the capping machine. Now, ladies and gentlemen, I recommend to fasten your seat belt. It is so impressive that you can fall down. I would not want to be responsible of an accident. Take a deep breath. You are ready? Take off. In order to demonstrate the new intelligent way to create sheet metal parts from simple solids, we will use this control box, divided in three elements: bottom, middle, and top. Let's first shell those solids. Here on the bottom, here on the back, and for the top part, we have to make some necessary opening. On the back, two openings, there and there, and on the top, a rectangle and three circles for buttons. And now, a last opening between parts to allow cable pass and connections. Let's convert to sheet metal. And now, for the bottom part, you see that in clicking on the top face, bends, junctions, and reliefs are created automatically in same times. Wonderful. For the middle part, just click on two faces, front and back, and everything is created automatically. We just have to choose the kind of meter, which is very fast using the amazing propagate capability that looks for the similar geometries and automatically applies meters. In matter of seconds, it's done, and we can unfold. Let's go now to the top part. First, we create the bends on the top face. You see that the related junctions are automatically created. Then, we repeat on the two back faces. Everything is created automatically, except the meters that need a choice, but with the propagate capability, it's just one click. Now, we create the curved junction on the bottom, on the top. There's still one choice to make the part unfoldable, but thanks to the possibility to switch bends and junctions, we decide to open on two sides. the part becomes unfoldable. Another important capability is the possibility to assign to one body its specific properties, despite the fact that we converted all the parts together. Here, we change the thickness of the bottom part. And now, we can unfold every part. You realize less than 4 minutes from those 3 solids to the unfolding. Just amazing. No one can compete. Here are also some impressive new features. We will use this strange device, a kind of drum that distributes the caps that will be crimped on the bottles. We start from the shell state, what we call poor sheet metal in BricsCAD language. First, we convert to sheet metal. Now, we will add a bend to this small part, but you see that there is a gap at the flange end. In V21, we can fill this gap in creating a sheet metal junction. Then, with our new T-tab function, we can switch this junction to tabs and slots inside flange and not only on the corner. Look at the result. And this is editable. We can change any parameter, for example, the number, and it remains symmetrical. Now, we will add 2 small flanges to guarantee the perpendicularity. And we will fix their width. And now, look at this. In moving flange by push-pull, the tabs and slots are moved accordingly. And now, even stronger. Even in rotation, the tabs and slots are moved correctly. Wow, I'm blown up. Then, thanks to the new capability of V21, we can change the thickness of this part particularly. And you can see that tabs, slots, dimensions, and the design intent are respected perfectly without any collision. And of course, we can unfold. Now, even greater. What about tabs on the curve? First, we set the number of tabs to 0. It means that the number will be chosen automatically according to the distance. Now, just click on the round edge, and miracle, we get tabs with a perfect distribution. Of course, now we must create a junction here to separate the parts. And to finish, just select the remaining part in a rectangle and click on Create Bend. Those solids are fully transformed in unfoldable parts. Finally, we can unfold all the parts. Very impressive. Now, let's have an overview. As every year, the new version brings with it a lot of useful new functions. Let's see. Now, depending on the way to produce, for cones and cylinders, we can choose between quadrangular or analytical unfolding. The result is, of course, slightly different. A very useful new feature. When the choice is obvious, the junctions are automatically created. It reduces drastically the time to get an unfolding part. Now, in converting in sheet metal, the chamfers on the edges are recognized as bevels and clearly indicated on the deixe. We have now the possibility to create tabs and slots inside a flange. We call this feature T-tab. It is necessary first to create T-junction. we can start from two different parts wherever in space that we connect to create the T-junction. We can as well create it from a single solid. We get automatically two parts. Those junctions can be switched to tabs and slots. But we can also create tabs and slots on a curved junction. The result is perfect. Another very useful improvement in a multi-body component, the characteristics can be changed individually for each body. Here, for example, we change the thickness. And now, the function convert in sheet metal recognizes the bends with a radius of 0. It is not anymore necessary to repair for unfolding. Thank you for your attention.
Thank you, Christian. The new sheet metal capabilities of BricsCAD Mechanical version 21 are really amazing, and from this demo, you should learn how many sheet metal parts are contained in this bottling machine. And this is so typical for many other mechanical assemblies. Imagine how much time will you spend to design them all without BricsCAD Mechanical. But there is one more kind of parts which are also very typical in mechanical engineering. These are seamless and welded pipes, elbows, teeth, crosses, reducers, and flanges. They are widely used in machinery, automotive, aviation industries. You can also find them in oil and gas, chemical industry, water supply. In BricsCAD version 21, we added a rich set of such parts of the most popular standards. We also streamlined the way to insert and connect them. Bottom-up design was never so easy. And we keep the freedom of direct editing in combination with full parametric control over the model. Let's see it in action. I'm inviting to the stage my colleague Evgeny Gromov, who will present you this new toolset.
Thank you, Dmitry. Hello, I am Evgeny Gromov, a development team leader in BricsCAD, and I want to show you new tools and features which we prepare for pipe design. For this demonstration, we will use a brewery model, which was created from scratch in BricsCAD. As you can see, this model contains around 800 parts and more than 1000 constraints between them, which mostly was added automatically during new mode of the BM insert command, Smart Insert. Let's check that even with such significant number of constraints, model is still workable. For example, to have access to vessels, we need to add a platform between them. Original platform is too big, but fortunately it's parametric, so you can easily change its dimensions to adapt to actual situation. Here we need to change heights and lengths. As you can see, now we have a problem. There are a few intersections between inserted part and existing pipes layout. We cannot change platform because we need to save it as small as possible, so we need to change pipes layout. But actually it's not a big problem since pipes layout is properly parameterized and we can just move it by manipulator or move or DM move commands. And everything, for example, placements or pipes lengths will be adapted automatically. So we need to move just one pipe and whole line will be moved properly. There is still intersection with valve, so let's move it also. Since our brewery becomes bigger and bigger, workers do not have time to do everything manually, and we want to upgrade it by adding some automation. For example, by adding filling line here. I think you remember this filling line by sheet metal demo. Here is our filling line, and now it looks like everything is ready for connection. But we cannot directly connect filling line with layout. We need to add pump, which will transfer beer between them. We do not want to place pump in front of required flange because it will block passage. So what we actually need is to place pump behind our flange, but it again will cause some modification of existing layout. Let's try to perform such modification and connect layout with filling line. And first of all, we need to rotate elbow with flange. It can be done by any rotation commands or just by manipulator. Such operation will preserve all required constraints, so layout still can be modified properly. Then we need to connect flange to pump. We can just directly move it or use BM connect commands, which were implemented to connect two parts which store inside information about how they should be connected. As you can see, outer diameter of existing layout does not correspond to pump diameter, but again, we have properly parameterized layout, so we can adapt diameter by changing only one parameter. So flange, adjacent pipe, and all other connected pipes and teeth will change their diameters properly. Let's continue. Now we want to connect pump to filling line. We can do it easily with the help of the new standard parts library and new option of BM insert command, smart insert. Standard parts library was reconfigured to improve usability. All existing parts was separated in three categories: fasteners, machine parts, and structural shapes. Category piping with 182 new parts was added. Mostly it contains parts from American standard, German standard, and international standard. Currently, piping category include following parts: pipes, fittings, for example, elbows, returns, reducers, eccentric reducers, teeth and crosses, a lot of different flanges, which are actually biggest part of piping category, and finally, there are gaskets. So, if we will drag piping part from library, by default, smart insert option of the BM insert command will be used. This mode can be used on components which store inside information about how these components should be connected to each other. This information is stored as a point and a line on special layer with postfix connection. And these entities represent connection point and connection direction. Also, this mode recognizes which parameters of base component can be used in inserted components and try to copy values or expressions of such parameters. This allows inserted part to adapt to base one and also will allow to create parameterized layout. One more thing which allows to create parameterized layout is proper constraining. So smart insert analyzes inserted and base parts and decides which constraints should be added to them to allow correct further working. And we continue creation. As you can see, when you hover inserted part to base one, its size is changing and it properly connects to base one. Moving and rotating of such part is still available and does not spoil parameterization. Moreover, because of constraints, adjacent elements are adapting to moving or rotating. Smart insert can be used not only from library, but also on already inserted components. So, as a final step, we need to actually connect created pipes to a filling line. Here for that we can use, again, move command, or in that case we need to position everything correctly and parameterize this connection manually. But we can also use specialized BM connect command, which will do everything automatically. You only need to point out which two components should be connected to each other. So, as you saw in BricsCAD 21, it is possible to create parameterized pipes layout, which can be easily changed if needed. Thank you for attention.
Thank you, Evgeny. You saw that assembling large parametric pipe system in BricsCAD is not more complex than connected Lego parts together. But to manufacture these assemblies, one has to properly generate the corresponding technical documentation. Let's see how to solve this task with BricsCAD Mechanical version 21. First, I'm inviting Alexander Yarovenko, who will explain you the process of creation of a set of drawing views for one of the vessels of our brewery.
Hello, I am Alexander Yarovenko, a development team leader at BricsCAD. In V21, we implemented new powerful tools to create associative two-dimensional drawing views from 3D model of the mechanical parts and assemblies. Let me demonstrate these tools to you on the example of the manufacturing drawing for a beer vessel. According to the standard, the main view of the vessel is a section view. To achieve this, first we should create base view beyond the layout and then create a section of the view in the view. Also, we create the top and bottom views that required for future annotation. For these views, we use viewProj command. The next part of the vessel is most important. They are responsible for prioritizing of the content of the vessel. The middle manhole subassembly does not completely fit into our drawings, but we can easily change their scale using the command options. The command options allows us easily customize the view during creation. The next step is not so obvious and could take some time because of subassembly orientation. It's not aligned with the coordinate axis. That's why to create the correct view of the top manhole, we use view-based command with current orientation options. These options inherit the camera position from the model space and use it in drawing views. It allows to create the custom views quickly and easily. The space on our layout is limited. We also plan to add annotations, table, and technical notes in the future. In V21, we introduce a new view break command that can reduce drawing views area by hiding their fragment. Let's create a vertical dimension and check how it behaves in combination with the break view. As we see, that middle part of the vessel is a perfect place for hiding. There is nothing important for production. Now you see that vertical dimension keeps correct value after the break operation. Break symbol has several properties. You can change the type of the symbol, for example, spline or zigzag, and other parameters, such distance between curves. We supported vertical and horizontal cuts and can combine both on one view. Fixation of the main manhole doors achieved by using threaded pin and knob. We implemented the new DM thread commands, which allow to create decorative thread to display the drawing views. Let's open in the pin component and add the thread. Using the new tools, we can easily create the thread on any cylindrical face. You can configure pitch, length, and diameter of the thread. Let's switch to the main assembly and create a drawing view of the pin. You can see that the threaded model displays correctly in drawing views. We put all necessary views on the drawing. It will be finished later. Now I propose to switch to another drawings, a very special one. Our partners help us with a couple of the drawing, but they prefer to work in old style using AutoCAD Mechanical. Unfortunately, after the receiving drawing, we noticed several mistakes that must be corrected. By default, when you open AutoCAD Mechanical drawings, some special symbol represented as proxy object. So we're able to apply changes to their object. You need to activate Mechanical 2D enablers and reopen the file. After that, you can modify 2D elements. We are supporting copy, move, erase, and other basic operations, but our capabilities are wider. For example, we see how we are scoping the datum ID using the manipulator. In V21, we added the ability to change properties from property panels. We corrected the feature control frame property, and now we're replacing fusion symbol of in the proper place. Let's open another file. Another example illustrates the assembly drawing. It allows us to demonstrate the ability to change balloon properties, such as balloon types, for example, circle, polygonal, and arrowhead style. In our case, we use standard arrow. As you see, the part list overlaps by other balloons, so we must correct this mistake and get the support bracket material. All this manipulation will take us a few seconds, and we did not ask the author of this document for help. Thank you for your attention.
Thank you, Alexander. So with BricsCAD version 21, you can break long drawing views, you can create custom parts with standard threads, and you can edit drawings created in AutoCAD Mechanical. But what about tables? Most mechanical drawings contain one or more tables. It can be a trivial part list or something more sophisticated. And Bill of Materials Managers or BricsCAD Mechanical allows you to create many kinds of such tables. Since version 21, its capabilities have become absolutely fantastic. And to prove it, I'm inviting Maxim Shilovsky, who will guide you through the advanced features of BOM Manager.
Thank you, Dmitry. Hello, everyone. My name is Maxim Shilovsky. I'm a developer at BricsCAD, and I'm going to demonstrate you the most interesting features of bill of materials in BricsCAD. And let's start with this brewery model. With more than 3,000 parts in it, you would need fast, flexible, and powerful tools to document and analyze it. And bill of materials in BricsCAD are exactly like that. For example, what if you want to see only parts related to piping, which this model has a lot? To do that, we add the part category column, and we will use a new feature, column filters. Similarly to spreadsheet processors, they allow you to set criteria which row to show. And here we use it to select those categories related to piping, such as elbows, flanges, pipes, reducers, and tees. And now we have a table of all parts related to piping. But what if we want to have the total length for each size of pipe? Again, it's possible. First, we will adjust the filter to show only pipes. Next, we remove the components column and add the size and length columns. Normally, BricsCAD groups parts with respect to their original definition, but we need to group parts with their size only. To do that, we change the grouping mode. In by columns only mode, BricsCAD will use only explicitly added columns for grouping, which is what we need. And to show the total length for each size, we will use another feature, aggregating columns. Similarly to footers, they allow you to see the sum, minimal, maximal, or average value for each group. And if you add another property, such as thickness, those aggregated columns will be automatically recalculated. And of course, you can add them to the footer. Or set a column filter for them. For example, if you want to see only pipes with total length between 50 and 100 meters. And notice that you can specify the unit in this dialog, quite convenient. Together, aggregated columns and column filters form quite a powerful tool, and we hope you will like it. Let's switch to the familiar drawing of the maturating vessel. As you can see, it's almost ready now, and all we need to do is to add some tables and place some annotations. And let's start with the material list. We create bottom-level bill of materials and rename it. For pressure vessels, we need to add physical materials and dimensions for each part. So we need to add necessary columns, such as physical materials, part category, part number, and length. But we would like to see them in one column. So we need to select those three columns and form a template column from them. It's a new feature to combine several properties into one column. It's based on so-called diesel expressions, so even quite complex conditional templates are possible. BricsCAD automatically adds delimiters between values, which you can adjust with your text. And of course, you can configure this template as you want using this configuration dialog. And now we need to remove no longer necessary columns, and we are ready to add this table to the drawing. Next table that we will add to this document is so-called nozzle schedule, and we start with the top-level bill of materials. We need to show only parts with nozzle or manhole in their names, so we will use new filter dialog to set these conditions. Simply select the property from a list, set the condition, and set the target value, which you can also select from a list. And now I will add the second condition. And notice they're automatically grouped together. There are two kinds of groups. All of group requires all conditions in it to be true, while any of group requires at least one condition in it to be true. It helps to create complex filters. Now we will add necessary columns such as item, size, service, and rating. And we also need to adjust the precision to avoid trailing zeros. It's possible with the new format dialog. Now we remove number and components column because we no longer need them. And we set the column rule for the item column to be the number, so BricsCAD will use its content as a source of number for balloons. And we are ready to place this table to the drawing. And notice you can change the corner of the table under the cursor using the Tab key. It helps to align your table to already existing ones. This drawing contains so-called nozzle orientation plan, which we need to annotate, and we will use automatic balloons to do it in just a few clicks. Here we use circular pattern, but of course you can place your balloons along any polyline as you want. And now it's done, under 5 minutes. Isn't it incredible? But of course we showed you only the most interesting features. There are much more. Try them with BricsCAD V21. Thank you for your attention.
Thank you, Maxim. It was so sophisticated, but have you ever seen any other mechanical CAD software which provides such advanced capabilities for BOM management with the same level of intuitiveness? By the way, BOM Manager got the highest number of support requests and feature requests, and we included most of them in our development roadmap. But now let me switch to a different subject which also has a relation to assembly design. In the previous years, we demonstrated you how you can use BricsCAD Mechanical to create exploded representations of your assembly in just a single click. Because this representation is based on analysis of collision between parts, it can be used to create assembled or disassembled instruction. And in version 21, we integrated this possibility into Animation Editor. Now you can create complex 3D animations which combine assembling, disassembling, kinematic simulation, and camera movement in a single movie. Let's see it in action. I'm inviting to the stage Ekaterina Filipova, who will explain you how it works.
Thank you, Dmitry. I'm Ekaterina Filipova, and I'll demonstrate how BricsCAD Mechanical V21 can help you to create animations of your products. This mechanism is a subassembly of the bottling and capping machine. It is known in mechanical engineering as Geneva drive or Maltese cross. I'm going to create a video that demonstrates the assembling process and also shows the kinematics of this mechanism in action. With BricsCAD, we've prepared the semi-automatic exploded view of the bottom level, which has been inserted to the model space. This is necessary in order to add the exploded view effect to an animation scene. Besides, we've created suppress groups for the model and exploded view, and added a special parameter named show exploded view, which is used in their conditions for easy switching. So, to start creating animation, we open the Animation Editor panel using a button on the ribbon panel. The duration of our animation will be 15 seconds. We can change it using the property bar. After that, let's add a timeline for automatic button 1 and add a timeline for our switching parameter. And then add a sequence for it with a value of 1 to show the exploded view. Then we'll create a corresponding sequence for the exploded view by double-clicking. Using the property bar, we can set exploded view steps and change their order. This exploded view has 44 steps, from assembled to disassembled state. Let's set the first step to 44 and the second step to 22. Also, we can add another effect for the exploded view. It was noted that steps of different sequences can be repeated. Okay, let's add the camera effects for assembling. For the first effect, we'll edit the current view, and when the effect is added as camera position, will be set by default. By the way, the camera could follow a selected path. We'll use it for the second camera effect, and we place the desired path on a hidden layer beforehand. Any curve could be a path. You can specify a path for a camera target as well. But here, we'll just set the origin as the target. So we can show the same step of the assembling stage from different points of view. Next, we want to show the kinematics of Maltese cross in action. And at first, we'll add a new sequence for the show exploded view parameter with value from 0 to 0 in order to switch to the original model. Further, we'll add an effect for the rotation angle parameter. It defines rotation of the primary drive. The driven wheel would rotate with pauses, so its rotation is described by a piecewise function of this angle. BricsCAD can achieve that by maximum, minimum, and signum functions, combined with trigonometry ones. Now, we add the sequences for transparent car parameter to show the rotary platform gear better. If the parameter value is 2, the plate above the drive wheel will be hidden. Thus, during this effect, we can observe the details behind the plate. Finally, let's add zooming based on the third camera effect. We'll select the prepared line for the camera path. The start point of the line is closer to the model than the end point, and it creates a zooming effect. And now we can animate the result seen using the playback buttons. Also, the created scene, if necessary, can be recorded into a separate video file. As we just demonstrated, with BricsCAD V21, it's possible to create impressive high-quality 3D animations. Note that this is just a small example. The editor allows you to create amazing video like the one shown at the beginning of the session. Thank you for attention.
Thank you, Ekaterina. So, three-dimensional animation allows you to see your product in action and check if everything is designed well and performs as expected. Using Animation Editor, you can create animated instructions for assembly, disassembly, and technical maintenance of your products. You don't need to buy any additional software for that. Everything is possible with BricsCAD Mechanical. Everything, including design, assembling, analysis, drafting, and animation. Isn't that great? But that's not all. Our development team has already started to work on the implementation of new mechanical features. They will be released in the next versions of BricsCAD. Please don't forget to send us your feature requests. We'll listen to them very carefully. And now, on behalf of Bricsys development team, let me thank you for watching us. Bye-bye.